коллеги.
Hello, dear colleagues.
Сегодня здесь видеть.
A pleasure to see you all. Thank you very much for attending this session. And on this beautiful sunny day, I would love to discuss with you application of ML algorithms and methods for the purposes of incident response. And, well, it's both about detection, investigation, and responding. I am Oleg Slepushenko. I'm the lead analyst at RT Protect SOC. Now let's hit the ground running. What has indeed led us to use machine learning in incident response? Let me give you the whole list. There are, in fact, so many reasons to do that. There is a huge pool of data that DFIR analysts has to go through, searching for the important events, and there is so much noise there. Take, for example, a table. In a regular machine, the number of events in a log can easily be measured in millions of lines. So obviously, there is filtering involved, and you don't really want your analyst to do that, because that would mean sending queries, creating filters, and that takes a lot of time. And 90% of the information you will be finding there will, in any case, represent the regular working of the operating system. So we need to be smarter about filtering. Now, this is also related to other items such as limited time. So, for example, it can easily happen that, you're taking like hours to, say, mount an attack, but it's only hours, right? So you want to respond in time as the defense side. And you want to have more evidence on the weights of your decision-making. Moreover, most companies don't have enough security people working for them because, a bunch of assets may have already been compromised, and then you need to run your investigation, identify your IOCs and facts of compromise, and that means that you will be running many more requests and checks. So you can have rule-based correlations for sure, but sometimes you don't really know the infrastructure you're working with. So, for example, an AR team may be summoned very quickly to intervene, and it may easily happen the company is not really working with any SOC, and they don't have much in terms of monitoring. And this means that we don't even know what's legit and what's not for a particular host. In other words, we do not have the analytics to filter the noise out. Moreover, the existing detection methods may easily be constrained. I'm talking here about correlation rules or static methods. Many of these are effectively, templates that run on a clock, and they tend to be pretty rigid. And over time, most organizations don't really change their correlation rules, and sometimes if they do that, they do it manually, when they involve their analysts. So, not surprisingly, working in tandem with a group of data analysts, we have tried addressing those issues.
Проведение расследования инцидентов, компромайс-ассессменты в том числе, можно ознакомиться по ссылочкам, предоставленным на слайде.
You can actually read more about the technical details if you follow the QR links, the QR codes. I'm showing here the 6 regular stages of IR. Obviously, there are many more, but we're only going to focus on what matters to us. After a particular response team, arrives on the site and they've done the regular, they've gone through the regular motions like identifying the critical nodes of the infrastructure, see if any nodes or hosts have been compromised. They've done the regular monitoring, in other words. So then we do the normalization and we send the information into the CM database for classification and clusterization to our ML model.
На данном этапе, на самом деле, первичном на сборе данных уже
So in this initial stage, the stage of data collection,
проблематика выступает очень явно. Это разнообразие инструментов.
we have already seen that there is a multitude of different tools that can be used, and the volume of information is mind-boggling.
Конечный размер.
Consider, for example, terminal servers. You know, the amount of data you can easily collect there can be like a gigabyte, several gigabytes easily. Now, I'm showing here several zips, such as sensitive files, and another one, we are going to discuss why they're there
Куда же без
a
нормализации?
bit later.
Собственно,
So let's
нормализация
start with normalization.
происходит все так же посредством ETL-оркестратора.
Normalization happens
Здесь
with the help of an ETL orchestrator.
процессинг, парсинг, вычисление.
So we do the full pre-processing, parsing, feature identification. Now, you may be asking me, why aren't you doing it in Airflow? And that would be, a valid question. But, initially, we did not expect to use ML algorithms for incident investigations. And in a sense, you can say it's a legacy code.
Экстракция как раз
In any
в одной
case,
из процессорных групп.
features are extracted in one of the processor groups, so to speak, and then they send in two streams for indexation in the same system and to the Airflow pipeline for clusterization. And there, depending on the source of documents, they will be clustered,
Процессорные группы на
or what's that? Identified, I think.
события происходит.
So you can see here that an event is being processed, and then it's being sent for incident description by the ML. But I'm sort of running ahead of myself here because this stage effectively happens a bit later.
Организации, которые оказывают услуги,
Next,
предоставляют услуги расследования
the
инцидентов,
organizations that offer the incident response services,
нормализации.
well, we ask them to
Понятное дело,
make
что
the best
крайне
use
редко
of the
происходит
existing
так, что,
logs, such as ODD and WinEvent.
собственно, исследуется после
Now,
инцидента.
it happens pretty rarely that on the user side you can actually find proper monitoring if the incident has already happened.
Но если
Like, I'm not really expecting ODD to be there, let alone with all the proper rules set up.
то это очень
But
сильно способно упростить
If
работу. и
things like this
качество
do
услуги.
exist,
Почему?
this can actually get you pretty far in terms of sort of preparing for
в некотором роде
the investigation.
да, то есть в рамках расследования инцидента это может качественно.
As part of the incident investigation, this can easily increase the level of your analysis and the quality of your analysis by a significant amount. Now let's talk about the usage of ML in investigation, or for investigation purposes. I promised to talk about PE headers and sensitive files, zips. That's exactly what we're doing now.
Информации в
At the stage of data collection,
две модели.
a particular triage agent will be sort of running two different models, where one is responsible for classification of malicious PE files. Why would we do that?
Методы, которые используются,
Well, the problem is that the modern methods,
с известными вредоносными, да,
such as, for example, comparison of checksums to whatever databases, is no longer that effective because malicious actors keep recompiling their binaries. You know, they do through one more iteration of obfuscation, which means that YARA rules are no longer as efficient as before. Because of that, we decided to try applying machine learning
продемонстрируем. То есть на основе
on the basis of decision trees.
скажем так, этот подход оказался не самым лучшим, и
Now, this has not been really a very successful attempt, though.
наилучшим образом.
And the next slide is going to show which algorithms proved to be better. Now, let's recollect what PE file contains. It's got PE headers, obviously. So obviously it's a C++ structure, so every field has its own value. And if I remember correctly, it has like 31 fields in a 32-bit file and 30 in a 64-bit file, and they can obviously be extended. So you can do feature extraction,
фичер-инжиниринг посредством вот этих
And feature engineering,
вычленения вот этих фичей и формирования новых каких-то признаков, которые
then you can create, say, new features or attributes that are going.
PE-файл позволяет это реализовать. В конечном счете мы имеем, да, некоторый PE-файл.
I'm sorry. So we do have a PE file, which then goes to classification.
Этот файл
And then, based on the model's verdict, this file can be archived
и дозаписан в JSON-файл в
and then can be added to the JSON file
классифицирован как вредоносный и был
to indicate that such and such file has been classified as malicious and therefore it has been quarantined or archived. Now, obviously, some files are not going to be archived. So if it's a huge file, we're not going to archive it, but you know it will obviously be flagged and locked.
Собственно, метриках, да, самым, собственно, что неудивительно, эффективным
Not surprisingly,
машинного обучения.
the most efficient algorithm is gradient boosting.
Но
However, random forest proved to be pretty good as well. Interestingly enough,
в связи с тем, что
I'm sorry, it's not random forest, but rather isolation forest. So since the depth of the trees keeps growing very fast and the size of the model gets out of control very quickly, therefore you cannot really run it on the edge, let alone on like 100 different hosts. In this respect, gradient boosting
что его метрики будут несколько лучше,
grabs the lead.
конечная модель будет весить там
Actually,
15 мегабайтов, что
in terms of other metrics, it is also better than isolation forest. But the ultimate model is only like 15 megabytes. Why not use transformers? Transformers obviously are gonna be better. There is no doubt about that. But let's go back to base one. The size of the model, if you're using transformers, will be at least 400 megabytes, which means that you won't be able to do both processing and classification on a single CPU. You will need to use a GPU for that.
брали PE-заголовки из-за необходимых директив.
In other scenarios, so you collect the PE headers from the right folders, and you send them to our infrastructure, and then locally in the infrastructure, we are already running a model which is based on transformers, running on GPUs, and it does a much better job of classifying PE files. So that's also a scenario possible.
Абсолютно. Переходим
Open
далее
to
к
debates,
поиску
obviously.
чувствительных файлов.
Now, let's talk about search for sensitive
Это,
files.
скажем, больше про compromise assessment, коль скоро
Now, this one is more about compromise assessment. So why would a perpetrator, say,
при этом
dump LSAS process in a hush-hush way
администратора в открытом виде лежит на рабочем столе.
if, for example, the admin password is easily available, or you can easily find a CSV table with all user passwords that were established at the stage when all the accounts were created. Very few corporations have a rigorous process for regularly changing user passwords. So you can use ML algorithms
Файл помечается как содержащий или не содержащий
to mark files up
информацию.
as containing or not containing sensitive data.
Положительного ответа, да, содержит чувствительную
So
информацию.
if it's marked as something containing sensitive data, it should go into a final archive. And again, that will really depend on the size of the file.
Опять же, да,
So,
почему BLSTM, почему не
Real STM algorithm is the one we're using here. Why this one? Why not the alternatives?
BLSTM
Well, the
показывает
situation here is pretty much the same.
модели, которые можно
It
перенести.
gives you the smallest model you can actually run on an endpoint while still giving you pretty good metrics, pretty good performance.
Классификация событий и выявление аномалий.
Now, event classification and anomaly detection.
И перед тем, как
Let's turn to the next chapter, so to speak. Before I actually demo it all, I should probably
да, то есть
show the classifier itself
упрощенно,
and the
разумеется,
architecture of the
но просто для
classifier.
образования понимания этого будет вполне достаточно.
Obviously, it's dumbed down, but I think it does get the message across. So we get an alert coming from the left. Its features are extracted, such as categorical values, textual ones, the
Опять же, на экране
figures, numbers. So the text data goes to BERT, and it shows its security BERT, which is a well-reputed model trained on a substantial corpus of data related to cybersecurity. And then it goes to Cat Boost as a feature.
по результату, соответственно, работы алгоритма мы имеем процент
Now,
вердикт о том, что
this
является
algorithm effectively tells us what its verdict is with a certain, confidence interval,
Я не стал, разумеется, здесь выводить...
and whether it requires any action or not. So there can be additional detail about, how we do ML metric monitoring. I'm just showing airflow here. If you're interested, I can go into the additional details that, we do have controls for data drift and other things, but this is not really that important. I'm just trying to show here that
На потоке сок работает.
I'm just trying to show what's happening in the production system in the SOC.
Просто обязаны мониторить состояние нашей модели, чтобы...
Well, we absolutely need to track the state of the model to make sure that we do not have a metric drift over time.
Прилетает сработка, соответственно, происходит
So,
ее обработка, да, и события классифицируются.
an event is fired, classification starts, and we get a verdict, whether it's anomalous or normal,
Как мы
requiring or not requiring any action. So you'll see that, we're showing something in red with 11%, I think. So it tells us that the probability of it actually being an FP, a false positive, is very low, but it's not entirely impossible. In fact, it proved to be a false positive in the end. But, the admins couldn't really say right away, what kind of script it was and why it was sitting in a shared drive and why several users had it in auto-fired mode.
Разумеется, это не какая-то единая модель. Это ансамбль.
Obviously, what I'm showing here is not a single model, it's rather an ensemble.
Коль скоро алгоритмы машинного
Because after all, this is the best practice now. Because in machine learning world, we do have lots and lots of specialized algorithms, otherwise we would have had very few algorithms indeed. So we can use, say, isolation forced, ILSTM, and BERT, for example, an ensemble like this. As I've already mentioned, the number of logs and the sheer volume of logs you find on the customer side varies, and sometimes, you actually don't get much. So if you don't have proper logs, if you don't have proper monitoring, it's easier to compromise an infrastructure like this. So there is a high probability we'll actually be dealing with a customer like this. Now let's look at what a model like this can actually discover. So isolation forest, for example, will cluster our data set and will be able to identify outbursts and outliers. For example, a typical time or an unusual length of an argument. So, for example, we may be limited in the kind of tools for identification we use. So I don't know correlators that can dynamically calculate the length of an argument. And I'm not talking about a pre-existing document that would be easy to translate into number of tokens. I'm talking about raw string analysis here. So outliers such as 25, 46, 25, 25s, one after the other, in a row.
Простое понимание того, что мы хотим добиться от конечной модели, которую используем.
I'm just trying to give you a flavor here for what we're trying to get with the model. So LSTM can help you identify an anomalous sequence of events. So take, for example, event ID 4625. If we have like 5 or 6 failed logon attempts, and the final one is 4624, and logon type is 10, meaning that they're using RDP, and it's also associated with an external address, well, that will obviously stand out.
Ну, опять же, да, обнаружит в кавычках здесь. И последнее, на BERT основанные алгоритмы.
And finally, BERT-based algorithms will be about mismatch of neighboring tokens.
Если мы сейчас посмотрим на
The tokens on the two sides of the one we're analyzing. Look, for example, at loading a DLL library as part of LSAS process. LSAS.exe and extreme.dll. It is very rare to see these two together, so this should qualify as an anomaly. So the model has learned on a certain corpus of tokens coming together. So although BERT must have previously seen both processes, but not together. So if they come together as part of a single event, that should be classified as an anomaly. So that should be flagged as suspicious user behavior, and obviously you can rename it so that, it tells you as an analyst something more actionable right away. But I'm just using it for visual illustration purposes here. Now, what about the infrastructure context? We would want the LM model we are using to understand the context of the infrastructure. At the same time, we don't want to retrain anything because it's long, it requires a lot of resources. That's why we decided to do it like this, to attach RAG to that. So, effectively, in the first stage of prevention, once we're doing interviewing and data collection, we can naturally grab data from AD or, similar systems or KC or CMDB or whatever. So we can collect the information that we need. After that, we can vectorize it so that it's all in the vector database, so that then we can use KNN to find the closest vectors. So once we vectorize information about the infrastructure, a user submits a question, this question or this query is vectorized and is compared on the KNN basis to the other vectors in the database. This way, we enrich the context for the LLM.
Пользователь может открыть любой документ.
So the way it works is like this. So a user can open any document in the CM system that they want to learn more about. It could be an NFT document, for example, maybe an event from Autorun list. Maybe something has been sort of written down. Or they can simply press the Ask button. And then they go into the web interface. And the initial event will be shown there as well. This is like additional context element. So the user then can ask a question of what kind of operating system is this host running? And they don't even need to indicate the name of the host because this value is actually shown in the document itself in a normalized way. So the user can query it for the IP address, for the CBs it's running, and the latest logon time, and the operating system, obviously. All this information will be fed through. Now, AD itself will maintain the latest logon time in Unix format, in seconds. Interestingly enough, some LLMs are not really good at converting this time, but the latest models are actually pretty good.
Но это, тем не менее, необходимо учитывать при условии того, что
please keep this in mind.
Хотите реализовать подобную...
If you're actually planning to do something like this for your own needs.
Но пользователь также может попросить написать...
Moreover, users can also ask for a DSL query to be produced by the LM to save their own time. If they don't want to spend their time doing the filter, so the LLM can reliably do this kind of work for you. So, for example, you can ask, find all the logons of this user in such and such period. The LLM will do that for you.
LLM, да и без описания артефактов, да?
So an LLM cannot exist without artifact descriptions.
Любое событие из
you can, or in other words, you can use LLM to generate artifact descriptions, even if it's anomalous.
Событие представляется в сыром виде, передается.
So an event is vectorized and sent to the LM model. The LM uses RAG to enrich the context, to bring in the TI feeds if needed. So, for example, if there is an IP address which has not been normalized, so it's not shown as part of the source list, for example. And you can also use, your inventory data as well. And naturally, you can pull data from MITRE-ATT&CK if needed.
В принципе, здесь необходимо учесть тот факт, что современные LLM...
So you got to take into account here that modern LLMs know quite a lot about cybersecurity. So they will know what event ID is, what's an anomalous event, what's a bloodhound, and so on.
По типу QN3, который...
So even the basic knowledge of QN3
Очень неплохо
which is the recent release I've already advertised, so to speak,
как это, опять же, выглядит.
are doing a pretty good job.
Человек, соответственно,
Now let me give you a demonstration of that. So as an analyst, you have identified an anomalous event. Now let's imagine you don't know much about this kind of event, so you want to get a short explanation. So you can press the button called Get Description from ML, and you can get the response from the LLM printed in the same document.
в PowerShell, который
Now, it's a script block in PowerShell coming from Hayabusa.
сама
So the LM takes this base64 code, decodes it on its own, and then it provides a step-by-step description of what each commandlet does,
и эффективно.
which is, super user-friendly and highly efficient.
Фильтрация шума и обнаружение аномалий.
Noise filtration and anomaly detection.
Какую сносочку сделать? Здесь мы...
What I should state here is that we're not so much trying to identify anomalies here, but rather to filter out potential noises. Like I said, those MFT tables can easily contain dozens of millions of entries, and 99% of this obviously are of no interest to researchers. And naturally, we want to minimize this noise without, splashing the baby out with the water. So imagine that we have 100 million documents, we are going to filter out 99.5 million of this, and that you can already manage, particularly if you got like 2 or 3 analysts.
График, да, и какие фичи.
Now, let me give you a visual illustration. So this is like a kind of a tornado chart, but differently. So it's a sharp graph, right?
Isolation forest, который по большей части, собственно, просто обнаруживает аномалии, да, всплески.
Isolation forest is good at identifying anomalies.
В конечном счете вердикт либо аномальный, либо нормальное событие.
So the verdict here is that it's an anomaly or a normal event. And you can see the metrics here.
Вносящие признаки в конечный вердикт модели — это временные.
The metrics that contribute the most to the verdict include the time, the day of the week when a particular document was created, modified, or deleted. So obviously what we have as a priority is weekends and nighttime. Now, if these are servers, for example,
сервер работает, это вполне себе нормальная история.
When you have a server running during the weekend, that's okay. If it's a user machine, it's highly suspicious. So now we see here a perfectly normal event, which is a creation of ETL log created in a regular directory, although on a weekend. So the verdict here is that it's okay, it's acceptable. So this particular event was classified as not containing anomalies, which is actually true, right?
Вобрал в себя все самые мощные метрики. Это создание...
So let me contrast this with the execution of an exe file on a desktop during the night. Early Monday morning on a user machine, like I said, and it was later classified as an anomaly, which is very proper, this host.exe file. And it actually turned out to be log bit 3, an encryption software piece.
Определено как аномалия.
This will be classified, this will be identified as an anomaly as it should. Now, in conclusion, I should say what we're going to do about the markup. So as we are doing incident investigation, we'll have a group of analysts working in the CM system, and they will add the suspicious events to an Iris-like investigation case.
По факту добавления данного события в кейс процесс...
Once you add a particular event to an Iris case, information is sort of fed back to the document, and then, it gets shown there that it's an anomalous thing.
До обучения модели. Здесь не вывел на слайд, но также есть дополнительные...
Now, I'm not showing you the slide here, but obviously there are additional functions for like a provision. Sorry. If we see that the model has not done a proper classification, we obviously need to inform about that, and there is also provided for. So we do get a kind of, natural markup
отдельно не выделяя на это время, а работая и
without spending extra time for that.
делая свое дело. Тавтологично. Получился в конечном счете вот такой некоторый жизненный цикл, да,
So we end up having
сокращенный и образный,
kind of a natural life cycle,
личное представление,
shortened as it may be.
что мы в конечном счете получили. Это автоматизация процесса.
What do we end up having? This is the process automation for noise, filtering out,
событий посредством
enrichment of events via RAG in the organization, infrastructure classification of malware, files that contain sensitive information and data on endpoints specifically, and identification, or rather classification and identification of false positives, FPs. Therefore, our plans are to streamline the process by reducing the amount of FPs, the events where an event is classified as anomaly. These two metrics need to be further improved. This is an automatic normalizer. When we work on the infrastructure, the end organization may contain lots of various logs which are not part of the infrastructure, like network events. We see IP addresses in logs. We don't have an initial source parser that would be identifying such fields as host IP, etc. So an automatic normalizer in this regard would be a great tool to use. Obviously, improvements of the P file classifier on endpoints, there is always room for improvement, and classification is not perfect at all times. The algorithms used are limited. And finally, in a perfect world, with the improvement of all the metrics and parameters mentioned above, is the automatic addition via an ML model to iris, so that an analyst can only analyze what has been analyzed. I'm repeating myself, by the ML model, filtering out what has been classified correctly. At this stage, I suggest that we proceed with the Q&A. Thank you for listening. Thank you very much for your contribution. Dear friends, a short organizational point. We have two areas with open microphones. Please come up to this microphone in the middle aisle of the room, and the second microphone is in the second aisle, closer to the far end of the room. Thank you very much for your contribution. A quick question of mine. At your company, to which extent does the SOC rely on ML solutions? There are differences between companies. There is very high distrust, and the opposite is high trust. That's a good question. Thank you. Answer. That's an endless struggle between how much we trust and how much we will be punished for over-trusting, where a model incorrectly classifies a respective event. We have verification by authorized analysts, which are on shift, and they check what ML says. So the trust ratio, so to say, is very variable. We do trust ML verdicts to a certain extent, but as they say, trust but verify. So we have always authorized analysts on shift, verifying specific events, whether they were closed correctly or not. Another clarification question. Do you have any period of time when you test out new ML features, whether you have a second opinion drop in pawn before you actually
Да, этот вопрос
use
он
these
решается коллегиально.
in real life. Yes,
Собираются
this
и аналитики
is a group decision. We have cybersecurity analysts and data analysts and the management.
единому мнению.
They convene and they then make a final ruling, final decision.
По
There
которой
is no single
работает одну неделю, все мы выпускаем. По какой причине ее нет?
decision. Why so?
Разные фичи могут в качестве
Various, this reason is pretty simple. Various features may contribute differently. A certain feature
воздействие на конечные
may impact the final processing
существенно влиять на
insignificantly, while others significantly impact the way analysts process incidents. For instance, if we realize that an ML is going to close incidents on its own and send notifications on its own, this is one thing. It takes a more thorough testing approach. If we have a model that does some spell checking, improving grammar, punctuation, we can somehow reduce the time required for testing. This depends on the contribution of a feature to the final changes to the process. Thank you. Let's now give the floor to the audience. Please present yourself and ask a question. As additional motivation, please be advised that those who ask the best will have prize for best question. My name is Sasha from Yandex. Thank you for your contribution. I work at the SOC. I have a question related to a slide. You have shown anomalies that can be detected by Ansibles, but to which extent is this available to an analyst? How do they deal with the results given by the Ansible? Thank you. Answer. Do you mean that without knowing the final result, what caused a given model or algorithm to classify an event as an anomaly? Let me clarify my question. Speaking of anomaly length in one argument, or things like that, I expect lots of false positives, FPs, and I wonder, therefore, among these, there might be anomalies worthy of interest. To which extent do analysts use this? You're not like piling up these verdicts on them. They must have a certain methodology so that they can process these anomalies efficiently. Answer, I see. This is rather about the fact, or rather the features and values that contributed to making a verdict. This story with identification of behavior anomalies, in production, it is not used. This is only for incident investigation. DFIR analysts do that. We identified an anomaly. Analysts open a document and verify whether the argument length is an anomaly. They can tell right away if it's opening up a browser in which it's going to have a huge command line, or rather, it is a coded 64 string. The purpose is not to identify anomalies only, without considering anything else. At one of the previous slides, I suggested that our job is to reduce the amount of noise, so that the sampling that does contain noise anyway will have much less noise, and we will then filter out events that were incorrectly classified as anomalies without losing the true anomalies that we are looking for real. This is not about specific information given to an analyst. What caused the model to classify a given event as an anomaly? It's about the fact that we are trying to provide a much narrower pool to simplify the work of filtering out events. Question: if I got it correctly, this is an additional field for analysts they can rely on in their search. Yes. Answer. We see the anomaly verdict, ml.anomaly.verdict, true or false. They can use that to narrow down the pool of events which are most likely to contain anomalies, rather than those that have been classified as normal ones. Thank you for your question. Next question, from the right-hand section of the room. My name is Vitaly. I'm an SOC analyst with P2. My question is this.
Используете большие языковые модели.
You use LLMs. At the same time, you use clients' data, which is pretty much sensitive. Do you run LLMs in-house? Yes. Thank you for the question. LLMs are being tested at our premises and tested. We have around 20 video graphics cards, around 500, 700 gigabytes of VRAM, which hold all the LLMs mentioned. The information does not leak out to the outside world, to no outside service, so we do not rely on IP. This is running on-premise. A follow-up question. Do you rely on some pre-trained models that you train further for your purposes, or did you build them from scratch on your data sets? It depends on the model. For instance, if we take BERT, for instance, these are pre-trained models based on a data set of cybersecurity. For monitoring, as the SOC operates, we enrich it with data we are receiving. But the basis, of course, is an ML model trained by someone else. For instance, BERT, we may have insufficient resources to further train it, but for isolation force and anomaly identification, there are no problems whatsoever. In-house resources may be pretty sufficient to write a respective model. Thank you so much. Thank you. Let me follow up quickly on this question. When data is sent to an LLM, do they depersonalize the data messages on your own, or the client does that? Again, when clients send you data, of course you have your own on-premise LLM. Clients send you data. Is this data depersonalized? No, they're being depersonalized in the process. This is one of the pipelines. So you have an agreement with the client that they provide everything as is, and it's okay with them. Answer. I'm not ready to answer this question yet, but in terms of depersonalization, it's obvious that sensitive data may be contained. Therefore, data analysts, they provision for that, because this is a relevant issue, very sensitive. These are host names, etc. This may reveal some internal specifics of an organization. These are being replaced. The details and the mechanics under the hood, I'm not covering these. Not ready to answer. Next question. Hello. Thank you for your contribution. I'm a student. How often is this used in real-life cases and investigations, and to which extent do lab conditions differ from real-life conditions? Thank you for your question. Answer. Let me start with the second one. To which extent do field data differ from lab data, the ones used for training of a model? Obviously, the data used for training of models, this is like day-to-day routine data, generated on machines of users, on virtual machines which contain nothing, which are empty. This data is super clean, super normal, like MFT tables. We're going to source from an accountant. They is going to have lots of anomalies compared to models trained on empty machines. This is a continuous process which needs to be taken into account in terms of the software running on a given host, the user group that belongs to the respective host, who works on that host, etc. Therefore, in this regard, the data to be collected from the end infrastructure is not matching, of course. But since the model is being trained on the data we collect, as a result, we get statistics which helps us to get the same data distribution to be collected from another client. This depends on the amount of data collected through the process of multiple investigations. Please repeat your first question. How many real-life cases? are there? Answer.
Наверное, 10 уже. Наверное, 10.
Well, in terms of quantity, around 10, I should say. Not all models cropped out at the same time. Some came earlier, others followed. The local classification of PE files and the search for sensitive data. This is the first thing. This is being used for around 1 year now. The classification of noise and filtration of noise, this has been running for 6 months now. And in the final build, how many of these? If we take all the models discussed right now, in terms of the number of models and of the amount of investigations they were used for, when all models were used, it's around 10. Thank you for your answer. Thank you for your question.
Серию вопросов.
Next question,
Спасибо большое за
right-hand side.
Николай.
Thank you for your contribution. My name is Nikolai. I'm an ML engineer with UserGate.
Получается,
My question is this.
данных для моделей классификации. То есть, если мы говорим
Data for classification models. If we refer to looking for anomalies, normally we
но если мы говорим
sample, we use normal data sets, but as we speak about classification, and the case in point is a model that classifies PE files,
выборку
first we need to get a huge sampling of normal files.
как-то к
The
различным
question is, does it adapt to various clients, or is this just a huge sampling from multiple files that work for everyone?
слововредными.
And the second part, the part with malware files, we need to collect a huge amount of these. And if we train the classifier,
В хедерах поменяет
if something changes to the headers by the attacker,
не отработать,
the classifier may fail to
собирали выборку.
work correctly. So how do you resolve this issue? How do you make the sampling? Thank you for your question.
Именно аномалии.
It's not about the identification of anomalies per se. If we consider an oscillation forest, we have gradient boosting, and we have a huge set of data with the values of headers that belong to malware files.
Такой же
And we have a balanced class for PE headers of normal files.
не встает вопроса о вычленении.
There is no question of identifying anomalies in terms of how much they differ
Уже классификацию
from normal files. This is
изначально у нас
about classification based on a huge data set of malware. We have balanced classes for this purpose.
сам PE-файл,
The fact that an attacker may change a PE file header,
и признаков,
there
которые
are lots of fields and attributes that we identify dynamically. So in advance, it's virtually impossible to guess what is the main impact. You change one field, and there are dozens, like 15, 20 and more fields. They still will result in this file being classified as malware. So this relies on a huge number of metrics. As a result of feature engineering, entropy of sections, code and data, this is identification of compiling file. This is the compiling time differs significantly, or it dates back
повторюсь, заключая это большое количество метрик и изменение
dozens or hundreds of years ago.
признаков не приведет
This is
классификации
a clear sign.
файла как
This will not lead to the classification of file as a normal one.
Так получилось, что просто
I have a clarification question. The robustness of a model is very high, and validation metrics are really high. Yes, indeed. You're absolutely right. Right you are. Thank you so much. May I ask another clarification question? You say that you have a sampling of PE files
признаки явно
where you have marked
выборка, она
specific
формировалась,
attributes, signs. So do you build this as the company evolves, or rather at the start of the project you launched a dedicated layout markup
огромное количество баз данных, соответственно, которые в открытом доступе присутствуют.
process? This is a huge amount of various databases, publicly available ones. You can find this on Hugging Face as well.
For
For malware PE headers, there's a huge amount of data available on the internet. If we wanted to build a similar data set in size, we wouldn't have sufficient resources to make this happen. It's more than 300,000, 500,000 malware headers. Obviously, training occurs continuously. As I suggested earlier, attackers keep recompiling their executive files and launching new obfuscation iterations. So, therefore, models require the addition of further attributes that would signal that this is a new type of software. This must be classified accordingly as malware. A follow-up question. In the event of a detection, when investigating an incident, do you take over a malware file sample to further use it within the company? Yes, we do. Further questions? We have plenty of other questions. Hello, thank you very much for your contribution. My name is Mark. I represent the SOC of Ozone Tech. I work as an ML analyst. My question is this. The isolation forest model, do you use it as a monitoring tool that provides alerts, or does it work on alerts that have been flagged already? None on flagging alerts. The isolation forest is just to filter out noise. We have unbalanced data sets without markup. We mentioned the MFT table. And we have a pre-trained system based on normal behavior of users and OS. And under this model, the isolation forest only works with documents that are signaled through new events. So for alerts, we have BERT. The BERT relays information to CatBoost. We also transfer category and values. So they operate independently. Yes, they do. And within this noise, you train the models based on when a file was created, in which folder it was created. Don't you fear that you pay attention to minor details more, and there might be a malware script in a normal folder at normal business hours, and you will miss it? Answer. This data is not deleted. This data is kept in the database, so it can be played with manually. The idea is the following. Analysts must be able to analyze the most likely anomalies as malware attempts, and the remaining chunk can be further monitored separately. So analysts will not miss an anomaly event in any case. It will just delay the analysis, and they will proceed with the most relevant ones first. Thank you very much for your answer. Hi, my name is Semyon. I represent data protection with T-Bank. Thank you very much for your contribution. You say that you have searched for sensitive data. You may find an encrypted, password-protected encrypted file on a desktop. Yes. Do you have any search tools for large systems like Confluence, etc.? How do you work with large data sets? Thank you very much for your question. That's a very relevant one. No, we never tried this because we had no need to. Databases, which are several terabytes large, we didn't have a case like that. What is this all about? We run something on a user machine, and we want to find some sensitive data they saved in plain text, like in a plain text document or in CSV file. And the case you are asking about right now, we haven't encountered one like that yet. Why am I asking? Because it's going to be a regular VTCAP system.
хотя бы недельные архивы поднимать, чтобы
So
анализировать.
probably you should pull up at least weekly archives to analyze these for analysis. That's a good scope for further investigation and study. I believe
Побеседовать с аналитиками данных на эту тему.
we need to talk to data analysts. Indeed, thank you very much. Thank you. You gave us food for thought. Indeed. I must take this opportunity to refer to the Positive Research magazine released by our company on the occasion of this conference. One of the articles on ML is dedicated to data protection. Therefore, the previous asker would be interested. Let me ask a question myself in the absence of other questions.
Олег, подскажи, как вы считали бизнес-value?
How did you calculate the business value of your ML features? The amount of employees, number of employees, and the payroll
Не были, скажем так, востребованы. Нет, никого не
was not utilized. No, of course, no one got fired.
по сей день.
And still,
Просто подспорье для аналитиков.
this is just an assistance tool to simplify the routine work of analysts. It's not about replacing an analyst. In any case, they're not getting replaced. Analysts are still in high demand.
Со стороны аналитиков данных, да, и со стороны, соответственно, организации.
On the part of a company that wants to introduce ML technologies, they want to simplify this process at least.
По факту
Instead of hiring a huge number of people who will be filtering out events. Modern algorithms help us make this happen. So the business value is obvious. It's for everyone to see. We can cover a greater demand in the market. So a client comes, the infrastructure has been hacked into, they want us to run an investigation. At the same time, an organization might have 3 investigations already running, and they may be understaffed to make this happen. Therefore, ML algorithms help filter out the noise, speed up the investigation process, increasing the quality. So this offers greater productivity, of course, greater productivity, and the need to allocate more manpower is delayed, to say the least. If it's not a secret, could you please share which models you touched upon are used on endpoints, on endpoint devices, or used by your colleagues who investigate issues on premise, and which ones are hosted in the infrastructure? We do not use a cloud-based model.
Ну, да, то есть...
I mean, inside of your own unit, models used on endpoints.
Как его? Ну, соответственно, алгоритм градиентный бустинг для
We
классификации.
have the gradient boosting algorithm to classify malware files.
Скорее всего,
Which framework was used? CatBoost, I suppose. CatBoost.
по BLSTM не
For BILSTM, I
которые вот у нас сейчас на стенде сегодня стоят.
don't have an answer. Please refer to the analysts working today at the booth and the exhibition area. So please make sure you come up to them at the booth.
Эмбеддингом,
On embedding, this is BERT, SecBERT. I just mentioned CatBoost,
только что затронул.
the one I touched upon earlier.
Ранее, до того, как соответствующие
And in the past,
модели вышли,
before new LLMs were released,
вихрь. Вот.
we used the Russian language Vicar-based, which understands Russian. I see, I got it. Thank you very much. Thank you very much for your contribution. You have a very difficult job. Out of all the questions, except for mine and those of Maxim, you are to select the winner for best prize, for the best question. Didn't you make a list? No, unfortunately, no. The context was insufficient. I'm sorry.
Вопрос. Давайте
Alrighty.
который дал пищу для
Let
размышлений.
it be the question that gave us food for thought
Данных про S3.
regarding S3 databases, etc. This gentleman over there, you are the winner for best question. Thank you very much. Thank you very much for your contribution. Please make sure you approach us at our booth. See you soon.